Okay, today we're going to review for the first test. And usually when I do this, I just go through the review assignment that I've posted. So I will go in and share my screen. I'm not going to be able to go through every single problem, but I'll get through as much as I can. And then when I teach my second class period, I'll be able to continue where I left off and then post both video links for you in an email. And I sent out an email reminding you about the test. And I think I had the wrong date in there. I had the right day of the week, which is Tuesday, of course, that we're going to have the test next Tuesday. But I think I said that was the 5th, when in fact that's the 7th. So September 7th, we're going to meet in room 3000 upstairs. You just need to bring a writing instrument. That's all you need. The calculator is provided for you on the computer. All right, so let's dive into this. So there will be some problems like this, where they ask you to write, it says, as x approaches 1, the value of 4x plus 2 approaches blank. So this is just understanding the idea of a limit. So when we have a situation like this, we're going to evaluate the limit algebraically. And that just means you're going to substitute the 1 into the 4x plus 2. And the way we write this in limit notation, you need to be able to understand limit notation, what it means. So let's see, this is problem 1. So here we say the limit as x approaches 1, and the function that we're looking at is 4x plus 2. So this is the way we write that. Let me stop sharing my screen so you can see that. So the limit as x approaches 1 of 4x plus 2, and we just substitute the 1 into it. And so we get 4 times 1 plus 2. Okay, so that's, there will be some basic problems like that on the test. Let's see here. And it's very important that you understand limit notation. So we have 4 choices here. And notice that you've got to really pay attention to where the sign is. If it comes after the number, that means you're approaching from the positive or negative side, depending on the sign. But if it comes before the number, it means the sign of the number itself. So C and D are actually the same. X approaches 2, x approaches positive 2. Well, 2 and positive 2 are the same thing. So that's, we are looking for the limit as x approaches 2 from the right. And so that would be choice A, because the fact that the positive sign comes after the number, that means you're approaching it from the right. Versus down here, the sign comes before the 2, that just means you're approaching 2, which it means the same thing as this here. So this is the correct choice. Okay, and again, you've got the limit notation. So let me just review that. That's really important for you to know is limit notation. And so you have the limit as x approaches, let's say 3 of your function f of x, okay? This is the limit as x approaches 3. The limit as x approaches 3 with a minus sign after it, it just means the limit as x approaches 3 from the negative side or from the left, okay? And then finally, the other situation is when you have the positive side coming after, and that's approaching from the right. Okay, so this situation here where it does not indicate left or right means from both sides. And so the only way that this can exist is if the left and the right hand limits are equal. That's the only way you can have a limit. Okay, so that's an important thing to note. Let me just write that out so you don't. Okay. Really important to understand that. Okay. This is the x approaching 5 from the left. So the limit as x approaches, it looks like B is the correct choice. Okay, another thing that you should be able to do is evaluate limits from a graph. This particular test has a lot of graphs that you have to interpret on it. So make sure you are comfortable with reading graphs. So here we're looking for the limit as x approaches 5. Now, because there is no sign following that 5, there's not a plus or a negative after the 5, we want to look at both the left and right hand limits and make sure that they're equal to evaluate the limit. So looking at this, the first step is to find x equal 5, because that's the value that we're approaching. So you go to the x-axis, x is approaching 5, so I've identified 5 on the x-axis. Then you want to draw a vertical line until you reach the graph itself. And notice on the left and on the right, they meet at the same spot, the vertical spot, okay? So limits are y values. So you're approaching x, but then the limit is a y value. That's why we have to go vertically up to the graph and then horizontally over. So the left and the right, they meet at the same spot. Therefore, the limit exists. And therefore, you can travel over to the y-axis and say that the limit is equal to 7, okay? So you start on the x-axis, 5 is the limit that we're approaching. You take a vertical line until you hit the graph. There you see the left and right-hand side both meet, and the limit therefore is 7 because that's the value at that spot, the y value. Limit values are y values. Very important to remember that, okay? So whenever you're asked to find a limit from a graph, it's always a y value, okay? Don't forget that. So in this particular case, the limit does exist because the left and right hand limits agree, and so the limit is 7. All right, now we have another graph, and we are asked to find the limit as x approaches -3. Now that negative is in front of the number. So I'm talking about the number -3. I'm not talking about the left-hand side. The left-hand side would be if the negative came after the number. See these little details? You got to really be careful. Okay, so the negative is in front of the number. So we're talking about a negative number on the x-axis. So I'm going to go to the x-axis here and find -3. So there's my spot. Now, what you'll notice is at that, as I draw a vertical line, the function value is right here where it's filled in. And so on the left, it's approaching this spot right here, which is at a height of 7. However, at -3 on the right, coming in from the right, it's down here at 5. So the left-hand limit is 7, the right-hand limit is at 5. They do not agree. They're different numbers. Therefore, the limit itself does not exist. Okay. The left-hand limit exists. It's equal to 7. The right-hand limit exists. It's equal to 5, but the limit itself does not exist because the two numbers are not the same. So they are asking for the limit itself because there's no sign here after the number. So it does not exist. Okay, they're easy to do, but they're tricky. You've got to really understand what you're doing. So just, here where it says the limit as x approaches 1 of f of x, our function is graphed here. So we look at the graph. Again, we're not asking for the left or right because there's no sign following this number. So we just want to know the limit itself. We go to 1 on the x-axis. So here's 1. Then we draw the vertical line till we hit the graph. Now, in this case, there's a hole there, but that's okay because in order for the limit to exist, all you have to do is have a left-hand and right-hand limits and that they have to meet at the same vertical spot. Okay, which in fact, on the left, it meets here at this vertical spot of -2, and on the right, it meets at that same spot. Yes. So it doesn't matter if it's just a closed one. Exactly, for limits. Now, for continuity, it does matter for differentiability, but for limits themselves, exactly. It can be an open or closed. So this one is -2. They both agree. They both meet at the same vertical height, which is the y value of -2. Remember, limits are y values. So the limit is -2. Okay, so now this time we are approaching -3, but you'll see there are two negatives. The negative in front means we're approaching -3. The negative behind here means that it's on the left-hand limit. So we're just interested in the left. We're not interested in anything else. So, so we first have to find -3 on our x-axis because that's the value that we're approaching. We're approaching -3 right here. I draw my vertical line. I'm not interested on the right-hand side. I'm only interested on the left, and it approaches a height of 8. So y value of 8. So it does exist and it's 8. Here we're approaching -1. I'm sorry, we're approaching 1 from the negative side because the negative comes after the 1. So I find my 1 right here and I'm looking again at the left-hand limit because the left is on the negative side of 1. So the y value, as I get closer and closer to this spot, the y value is 2. And again, it doesn't matter that there's a hole there because limits are near values, not at. So at that spot, at 1, the function value is right here, see? But we're not talking about the function value, we're talking about the limit. So we want to know what is happening close to 1. So on the left-hand side, if you get close to 1, you're getting closer and closer to 2. So 2 is the limit. Does that make sense? Okay, good. So now we're approaching 3. We go to our graph on the x-axis. 3 is right there. Now there's no sign after the 3. That means we want to know both the left and right, and they have to match. Okay, so the left, coming in on the left-hand side, we're getting up here to, what is that, 5? And then on the right-hand side, we're coming in down here at the height of -6. They don't agree, and therefore the limit does not exist. Okay, now approaching 3 again, but this time the sign tells me we're approaching it from the positive side. So we're just going to look at the right-hand limit. And if you go to 3 right here, these always throw me off because I'm attracted to that break there. But if you'll notice, the break is at 2. And they want to know what is the limit as x approaches 3. So don't get tripped up by that. So there's the 3 on the x-axis. And notice that the function itself is crossing the x-axis at that point. So I'm already there. And the height, what is that height on the x-axis? What height is that? 0. So the right-hand limit is 0. So that one's kind of tricky because if you're churning through these, you want to go to that break, and it's not at the break. It's near. It's at 3. So that's kind of that'll throw you off. Approaching 3 now, because there's no sign following the 3. We want the left and right limits have to match in order for it to exist. So I find 3 on my graph, which is right here. And it looks like the left, if I draw vertically, go to the height of 1 there, both the left and the right meet at that spot. So the limit does exist and it's equal to 1. What did I do wrong? Did I go the wrong spot? Hold on. What am I? Let me blow this up. So we're looking for the limit as x approaches 3 of h of x. Use the graph h shown to the right to find the limit. If necessary, state that the limit does not exist. So I'm, as x approaches 3, and here's 3. And if I go to the graph, it's right there. Oh, I see. That's not 1. I wasn't being careful. Each little box is half a unit, not 1. So if you draw the vertical, so that height right there, notice that there are 4 units from 0 to 2. Therefore, each unit is a half. So that's the mistake I made. Kind of going through here too fast, not paying attention to what I'm doing. Okay, that's better. All righty. Use the graph. Now x is approaching -4. There is no sign after the -4. So that means we want to make sure the left and right agree and then meet at the same spot. And so we're looking at -4 on the x-axis. It's right here. And again, as I draw a vertical line, there's a hole there, but for limits, that's okay. For continuity, that's not okay. But for limits, it's okay. So the left and right do meet at that spot. And so the limit does exist. And the height at which we are, remember, limit values are y values. So we're going to go over to the y-axis and the height is 1. So we have a 1 there. In this example, we're approaching 2 from the negative side. That means we're interested in the left-hand limit. So I go to the x-axis, I'm looking for 2, and I find 2 right here, and I draw a vertical line. Now remember, we're interested in the left-hand limit. Obviously, there's a break there. The limit does not exist because the left is up at 7 and the right is down at 1. But remember, we want the left. So I'm going to pick the left side, comes in here at a height of 7. So the left-hand limit is 7. Okay. All right. We're approaching 1. And I encourage you, if you haven't done the review yet, go through these on your own. I know I'm going through them. And so if you get confused, you can go back to the video and check and see, but try to do it on your own to practice for the test. But I find that these problems are the ones that students have the most difficulty with, is looking at a graph.
Is there a review due tonight?
It's due on the day of the time, at the morning of the test. So you can work on it as you study. Yeah. Okay, so as x approaches 1 of our function h, and we want, notice there's no sign after the 1, so we want left and right together. So if we go to 1, you can see the left is at 5 and the right is at 0 because it's on the x-axis there. So they don't agree, therefore the limit does not exist. Even though the left-hand and right-hand limits exist, the actual limit itself does not, because they have to agree. Okay. This time we're approaching 7, and same deal. You'll see there's a break. The left is 8, the right is down here at -2. They don't agree, so the limit does not exist. Oh, I did something else wrong. I think I'm going too fast through this. I did it. I always do this mistake. So this is a good lesson for you all. Don't make this mistake. I saw the break there and I thought, oh, that's the one I'm looking at, but I was doing it too quickly. They want as x approaches 7, and this spot right here, x is 5. So I was in the wrong spot. So here, 7 is right here between 6 and 8, and therefore you can see the left side and the right side, they do meet right there. Even though there's a hole, they do meet. So the limit is what? What is it? Exactly. So be careful, because I do that mistake. I make that mistake all the time. My eyesight is attracted to that break in the graph, and they're tricky. They're being tricky, kind of. Not really, but sort of. For me, they are. Okay. Don't go through these too fast. Okay, now, here we're supposed to graph the function. I don't think I have any problems on the test where you actually have to graph a function. But if you use this utility, this is an absolute value function, which is a v. So you choose that. And if you want to find the vertex, that is when the function value is 0. So that would be at 3. So right around here at 3. And let's see, how does this work now? And then another, if you plug in, so if you plug in 3, you get 0. If you plug in 1, you get 2 minus 6, that's -4. So that when you take the absolute values, that will be 4. So at 1, you're at a height of 4. So let me see if there we go. That looks good. Double check, make sure I did that right. There's a 1 at 4. Yeah. Okay, so that's how you use the graphing utility. I'm not really big on graphing because you have your graphing calculators. which you can use. So I don't think I have any problems like this where you have to use the graphing utility. But anyway, now we want to find the limit as x approaches 3 and the limit as x approaches -1. And because this is a continuous function, you're never going to have a situation, there are no breaks. So you don't have to worry about the left and right hand not agreeing. So all you have to do to calculate these limits is plug the 3 into the function. So as the limit as x approaches 3 is going to be 0, and the limit as x approaches -1, here's -1, and you can see it's up there at 8, or you can just plug -1 in. -2 minus 6 is -8, but when you take the absolute values, you get 8. So we'll just, the answer here is going to be 0. And then the answer here is going to be 8. Okay. So I don't want to spend too much time on these type of problems. We've done quite a bit of. Okay, let me just talk for a moment about limits of infinity. Okay, so here we're approaching, we have a rational function, and if there's, the limit is going to exist wherever the function is continuous. So remember, if your function is continuous, the limit will always exist at that point. So this function is continuous everywhere except at -2. And it kind of separates. So here the limit does not exist when x approaches -2. But what the limit as x approaches -1, it will exist. So let's pick the right graph. First of all, the problem is you can't divide by 0, so -2 is a problem. So I'm going to look and see which one. This one, let's look at this one here. You can eliminate C because the break occurs at 2. And remember, our problem, the break has to occur at -2 because that's in the denominator. So this one is eliminated, as well as this one, same thing, it's at 2. We want it to be -2. And so which is the correct graph? Well, you can just, if you look at this one, and if you plug in 0 into your function, you get 2.25, 2.5, because you plug in 0, 5 divided by 2 is 2.5, and that's right here. So this graph works, but A does not. So B is the correct choice, because if you look at graph A, if I plug in 0, there's nothing at 2.5. So this is not the correct one. So B is obviously the correct choice. And then you can just plug in the limit for -1. It's going to be 5, -5 or 5. 5, I'm plugging in -1 for x. 5, -1 plus 2 is negative, or is +1, -1 plus 2. So 5 divided by 1 is 5. So that's the limit. So when you're solving limits algebraically, as long as the function is defined at that point, you just plug the number in. That's all. So that's what I did there. Just plug it in. And here, plugging in -2, remember, we can't do that. The limit does not exist at -2. Okay, this one is a similar problem. I'm going to skip over that and talk about this one. Okay, this problem, there are a lot of problems where I don't want to say a whole bunch, well, probably several, quite a few problems where you have to have a function defined piecewise. See how that function is defined? So let me just talk about this for a moment. I'm going to copy this down and just talk about it. So here we have f of x is equal to 4x plus 9 and x. Now remember, you can use the graphing calculator on the computer there. So if you feel comfortable just graphing using the graphing calculator, you're welcome to do that. I don't use that particular calculator at all, so I'm not familiar. So you want to go in there at some point and familiarize yourself with it. And just to be comfortable for the test. That's in room 3000. It's open from 10 to 5. Today it closes at 5, and then on Friday it closes at 2. Monday it's open again from 10 to 5. So take a time to go over there and just check it out. Let's see here. Just a second. I'm going to check something. Okay, so they are asking to find the 3 different limits. First, the limit, the left-hand limit, then the right-hand limit, and then the actual limit itself. And with functions defined piecewise, the whole thing is at the joining part. So this, let me stop sharing here for a second. This is the spot where the 2 functions are joined together or not. They may or may not. That's what you have to decide, okay? So when you're calculating the left-hand limit, okay, we're approaching -2 from the left, okay? You have to decide which one is the left-hand side. Well, obviously that's this one here because x is less than -2, so it's on the negative side of -2. So this is the left, and then when x is greater than or equal to -2, that is the right. So if you're calculating the left-hand limit, you want to plug -2 into the left-hand side, so 4x plus 9. So the left-hand limit, that's this little negative here, means I'm on the left, goes, I take my -2 and plug it in. So I go 4 times -2 plus 9 equals -8 plus 9, which is 1. That's the left-hand limit. The right-hand limit, when x approaches -2 from the positive side of your function, f of x, well, now we want to plug in on the right. So here's the right because x is larger than -2. So that's right, the right side, plug in our -2 because that's what we're approaching. Just plug -2 in for x and you just get -2. So the left and right do not match. So therefore the limit does not exist. So the limit as x approaches -2 of your function f of x does not exist. Okay. Make sure you understand that. There are a lot of problems like this where you have to decide which one is the left and right and then calculate the limits. Okay, so make sure you understand that. Someone has a question here. Let's see. Oh, you know what? Thank you for pointing that out, Jack. Monday is a holiday, so I guess it probably will not be open. Thank you for reminding me of that. So I was talking about the tutoring lab, and Monday is a holiday. So it looks like today is your last chance, or Friday or tomorrow, to get over there. So thanks for pointing that out. That's a good comment there. Okay. Moving on. Let's see what else we got here. Okay. I didn't graph it, so let me, this time I'll look at the graph. I forgot to do that on the last problem. But here we have g of x is equal to x squared and then minus x plus 6. So the top one is when x is less than 2, and the bottom one is when x is greater than 2. And notice at 2, it does not exist. The function does not exist at 2 because we have strictly less than, strictly greater than. And so on both sides, we have a left and right hand limits, but let's check this one out. So before I do that though, we can eliminate B and D for our choices because notice for these graphs, the function value at 2 exists. There's no hole there. So this one is out. And also this one is out. You would want a hole there because the function does not exist when x equals 2. And if you draw a vertical line from the x-axis, here I am at 2, draw a vertical line, there's no hole there. So B and D can be eliminated. The choice is down between A and C. And you'll notice that my function is a quadratic. The top one, when x is less than 2, is x squared. So that's a parabola. So that would be the left-hand side because x is less than 2. You're going to have a parabola. So this one is out because notice both functions are linear, or actually the right side has a parabola. Let's look at that. There's a slight curve here. So the right side has the x squared function, but we want the left side to have the x squared because x is less than 2. That's the left side. So A is the correct choice for the graph. Then we have the limits that we're calculating. The limit as x approaches 2 exists because notice at 2 here, they meet. The left and the right meet there when x equals 2, and that height that they meet at, now you have to be careful. You're starting at 0, and in 5 units, you're going up to 10. So this height is actually 4. And so the limit exists and it's equal to 4. Okay. There is a problem like this on the test, so let me show you how you do this one. I'm pretty sure actually there are a couple like this, 2 of them. There are 40 questions altogether, by the way. And there are 2 that require you to find the constant. I think in one you're looking for C and in another you're looking for K. So here we have f of x is equal to 1/2 x plus C when x is less than 2 and minus x plus 8 when x is greater than 2. And the question says, determine the value for C so that the limit exists. Okay. So basically the left hand, this is the left, and this is the right. In order for the limit to exist, they have to be equal. So first, let's calculate the limit on the left. And it's just plugging in the value 2 into our function. So the limit as x approaches 2 from the left of our function f of x is equal to 1/2 times 2, right? My x is 2, so I'm plugging 2 in, plus c, and that's going to be equal to 1/2 times 2 is 1 plus c. So this is the left. And then the right, oh wait, I'm sorry. I forgot to stop sharing. So there we go. Sorry about that. Let me start over. So here's my function. The left is this limit. I'm taking this function. I plug in 2. And so 1/2 times 2 is 1 plus c. And then on the right, x is greater than 2 on the right, so I plug in 2 there. And I get 6. Now, in order for the limit to exist, okay, these 2 have to match. So all I do is I say that 1 plus c is equal to 6. And then I subtract 1 from both sides to solve for C, and I get C equals 5. So if C equals 5, then the limit will exist. If C is not equal to 5, then there's a break. And it won't exist. So that's how you do those. Pretty simple, but a lot of people miss this one because they don't know what to do with it. But it's just plug in 2 in both of them, then set them equal and solve. And there you go. It's not that hard. Okay. If I forget to stop sharing my screen, let me know so I don't do that. Just holler at me. Here's another problem. Same thing. I'll let you practice this one just to save time. And let's see here. Use the theorem on limits of rational functions to find each limit. If necessary, state that the limit does not exist. Okay. The theorem on rational function limits, that was the one where 0 was dividing by 0. So if you ever are solving a limit algebraically and you get 0 divided by 0, you need to factor, okay? So we'll do some examples. This one is not a rational function. You just plug it in. So you don't even use that. Okay, so here we have the limit as x approaches 4. I'll just do it. Wait, what was that? 2x. I forget what it was. Hold on. 2x plus 1. This is just a linear function. You just plug in 4 and you get 2 times 4 plus 1, 8 plus 1 equals 9. So the limit is 9. Okay. That's not so interesting. That's an easy one. There are probably at least one easy one like that on the test, but the one that gets people tripped up, let's see, that's another one. Just plug in. Here we go. This is a rational function. So it may be that you're going to have to factor. This particular problem is a little tricky just because it looks like you're plugging in 4, you're plugging in -4, but remember a double negative is going to give you a positive. So you're really going to just have 8 in the denominator. So this one isn't going to pose any trouble, but let me just do this one so you can see what I'm talking about. So I'm going to copy it. X approaches -4, x squared minus 2 over 4 minus x. So again, this is a 4, by the way. You plug in -4, you're going to get -4 squared minus 2, then 4 minus -4. So you have 16 minus 2, 4 minus a -4 is 8. So it's going to be 14/8. So that's pretty easy. That's again, just plugging the number in and calculating it. Okay. The problem occurs is when you get 0 divided by 0. That's where the problem occurs. Oh, I must have made an arithmetic error. What did I do? Oh, simplify. Thank you. That's what I forgot to do. So 7 divided by 4. There we go. Okay. By the way, if you make a mistake like that, I'm not going to take off all the points you get. You know, you are supposed to simplify it, but I always usually just take maybe half a point off or something like that. So don't worry. You will see your score after the test. You will see a score, but often that score will change because I add points for partial credit. I don't do that on the multiple choice questions, but on the ones where you just enter it in, I do that. So, okay, here's the problem I was talking about, where you have to use the theorem on limits of rational functions. So we have here the limit as x approaches -10 of x squared minus 100 over x plus 10. So your first step, just like the last problem that I did, is to plug in the -10. So we get -10 squared minus 100 and then -10 plus 10. So this becomes 100 minus 100 over -10 plus 10, which is going to be 0 over 0. Whenever you get 0 over 0, that is your clue. This is important. Whenever you see this, it's your hint to factor. One of those, whenever the fact that you get 0 over 0 plugging in the same number means that there is a factor in there. And what is the factor? It's going to be x plus 10. So I factor the numerator. This becomes the limit as x approaches -10. When I factor this, this is called the difference of squares. And the difference of squares, if you will remember from algebra, I don't know if you remember this, a squared minus b squared equals a plus b, a plus b times a minus b. Remember that from algebra? That's the difference of squares. So here, when we factor this, becomes x plus 10 times x minus 10 divided by x plus 10. And now you can see that common factor showing up. And so this becomes, by that theorem, the limit as x approaches -10 of x minus 10. And now we can plug in -10. -10 minus 10 equals -20. So this is our limit. So even though the function value is undefined, the limit does exist. So there's going to be a hole in this graph, and the hole occurs when x is -10, but the left hand and the right hand meet. And so they look like this line. It's the line y equals x minus 10 with a hole in it. That's what this function is. Okay. So that's how you do those problems. Just be looking out for the 0 divided by 0, and then you know what to do. Okay. Same problem, factor. You're going to plug in 3, you're going to get 0 over 0, you factor, and then plug in the number after you factor. Here, you're just plugging 4. Don't be bothered by the radical. You plug in the 4, 5 times 4 is 20, minus 3, square root of 17 is your limit. So same thing here. When you plug in 15, now they want the right hand limit. Okay, so the right hand limit means that x is greater than 15. So if you think about this graph, I would use, quite frankly, I would graph this if it were me. When you want to know that the function exists on the right hand side, but to me it does look like it exists on both sides because of that square, except when you get outside of the range of 15. I better just graph this. When you get to a problem like this where you're not sure what's going on, the best thing is to graph it. And I wouldn't put anything this complicated on the test anyway, but I'll just quickly show you how that works. Hold on. You're not allowed to use Desmos, but you can use the graphing calculator. But I wouldn't put one like this on the test anyway, but you can use the graphing calculator. So here we go. What was the function? Now I forget. Oh gosh. I don't want to waste time. I'll come back to this one if we have time, because I want to get through at least half of the review so that I can do the other half in my next class. So I know that there's not one like this on the test, so don't worry about it. This one's, I'm trying to think, it would work. The range, what is the range of this function? It doesn't exist if the number is less than 225 or the distance. And so it exists as long as it's the absolute value is greater than 225, it exists. And so you're getting something like, so it does exist. And if you plug that in, you're going to get 0. So just plug it in. There we go. Now continuity, that brings us to continuity. So we're done with limits. Continuity, now the limit has to exist and the function value has to be equal to the limit. So it's a little bit stronger condition. So let's talk about continuity. And from a graph standpoint, it's very simple. Can you draw it without lifting your pencil? If you can, it's continuous. It's pretty easy. So for these, when you see a graph like that, it asks you, is it continuous over the interval? You just take your graph and try to draw it without lifting your pencil. And there's a break here. Because I had to lift my pencil at this spot when x was equal to 3, there's all it takes is one spot for there to be a break, and it's not continuous. So this one is no. Again, there's a break right here. Here's the break. Let me make sure I'm sharing my screen right for those of you who are zooming. Good, looks like I am. Okay, here's a break. Therefore, it's not continuous. So no. See how simple these are? They're really pretty simple. This one is asking you to break it down a little bit. Okay, so let's, but we've had a lot of practice doing this already. It says find the limits, the left and the right. That's part A. We have to find the right and the left-hand limit. Then they want you to find the limit itself. And then they want you to find the function value. And then they ask you, is it continuous? Obviously, it's not continuous here, but the question is it continuous at 3, right? At x equal 3. So you look at your graph, you go to 3, 1, 2, 3, right here, there's a break. So at 3, it's not continuous. The left-hand limit is 2, and the right-hand limit is at a height of 4. So on the left, it's 2, on the right, it's 4, so it does not exist at that spot. So here we go. Right-hand limit was 4. Left-hand limit was 2. Therefore, the limit does not exist because they don't match. And therefore, it's not continuous. Okay. The function. Oh, they want f of 3. Okay, let's talk about that for a moment. That's a good question. What is f of 3? F of 3 is what you get when you plug in the number 3. So here I'm at 3 on the x-axis. Remember, the x values are what you're plugging in. How do I plug it in? Well, you draw a vertical line until you hit the graph. There's a hole here, so I'm passing through the hole and I hit the graph right here. And the function values are y values. So once I plug in the 3, now I got to tell you what's coming out. Well, I got to go to the y-axis. We're at a height of 4. So f of 3 equals 4 because I passed through that hole there and hit that filled in spot there. Okay, so f of 3 is 4. Then finally, they ask us if the function is continuous. And why is it not continuous? Okay, there are 2 requirements for continuity. So I'm going to pause here and I'll come back to this. Let me discuss the requirements for continuity from an algebraic standpoint. It's obvious from the graph. We can see that it's not continuous because of the break, but why is it not continuous? Okay, so let's talk about that for a second. Whoops, what did I do? Okay. So continuity, there are two requirements. For a function to be continuous, I think I lost something in there, a U, continuous at x equal to some value a. Okay, in our example, it's 3, a is 3, but we're just talking about in general for any number a. Okay, first, the limit as x approaches a of your function, we'll call it f of x, must exist. Okay, and the limit as x approaches a or of f of x must equal f of a. Those are the two requirements. The limit has to exist. In other words, the left and right hand limit have to exist. And then the function value at a is equal to the limit. So those are the two requirements. So let's go back to the problem and see which one fails. So going back to our problem, we know it's not continuous. That's pretty obvious. But which one, is it B or C? F of x is not continuous at x equals 3 because f of 3 is undefined. Is that true? Is f of 3 undefined? No, because we found f of 3 to equal 4. Remember, there's the filled in dot. If that were an open hole, then obviously it would be undefined. But when you have a hole, filled in hole, that means it exists there. So it's not undefined. So this is obviously not the right reason. The reason is the limit does not exist because the left and right hand limits don't match. So C is the correct reason for that one. I'm pretty sure there's a problem like this on the test, but if you get stuck on part D, it's not going to kill you if you get it wrong, because once you've worked through all these problems, sometimes conceptually people struggle with this, but it's worth a fraction of your problem, so it's not a big deal. It's like 1/4 of, there are 40 questions, so each problem is worth 2.5 points. So you're losing 1/4 of that. It's not a big deal, but that's the reason. Oops, hold on. Okay. I have not completed this question. Okay, checking answer. There we go. Is the function given below continuous at x equal 5? Why or why not? What kind of function is this? 9x minus 5. It's a linear function. So a line is continuous, right? You can draw it without, that's one way of answering it, or you could just calculate the limit. The limit as x approaches 5, you plug in the 5, 45 minus 5 is 40. The limit is 40. And if you plug 5 into the function itself, the function value is 40. So they agree. So therefore the limit exists. And I mean, the function is continuous. But you can just look at it. If it's a polynomial, here's another linear function. It's continuous. Let's find a more interesting one. Aha. Here we have one where there's a break at x equal 2. So the question is, let's work through this one carefully because this can be kind of tricky. So I'm going to copy this down. F of x equals 1/2 x plus 7 when x is less than or equal to 2, and 5x minus 2 for x greater than 2. Okay. The question is it continuous at x equal 2? All right. So first off, we want to make sure that the function value exists. And so if we plug in f of 2, remember for a piecewise defined function, you have to decide where this is in the domain. Okay, here it is. 2 is in this, x is less than or equal to 2. So 2 is in this part of the domain. And therefore, you're going to plug 2 into this function. So you're going to have 1/2 times 2 plus 7. And that's going to be 1 plus 7, which is 8. All right. Now the limit exists if the left and right hand are the same. So here is the left, because x is less than or equal to 2, and here's the right. So the limit as x approaches 2 from the left of our function f of x, we plug it in here, as we just showed, is going to be 8. And then we're going to do the right hand side. Now we're going to use this one. So 5 times 2 minus 2. So it's 10 minus 2 is 8. They all agree. And so therefore it's continuous. And in order for it to be continuous, you always have to have all of these agree. This is the function value. This is the limit. Remember, the limit exists if the left and right hand limit are the same. So okay, there you go. So again, not so hard to do, but you got to know what you're doing. That's the thing about this test. Problems are easy, but you have to understand what you're doing. So now it says the function is continuous, which is the correct reason. So B and C, the function is continuous at x equal 2 because f of 2 does not exist. Well, that's obviously not true. So C is the correct choice because f of 2 is equal to the limit, which is equal to 8. So that's the right choice. Okay. Same thing here. Same type of problem. I'll just let you practice that. If you plug in 5, you get 1/5 of 5. 1 plus 3, that's 4. If you plug in 5 here, you get 16 minus 12, that's 4. Yes, the function is continuous. They agree. The left and right hand agree. Well, maybe not. Oh, hold on. What did I do? I'm going too fast again. What did I say? Oh, yeah. I meant to select, no. Oh, 5, 1 plus, oh, I know what I did. I plugged in 4 down here. 4 times 5 is 20 minus 12. And I said 16 minus 12. So that's why. Yeah, I was wrong. Sorry. Similar question. Let's try that again. Plug in 2. 1/2 times 2 is 1 plus 3. That's 4. Plug in 2 again. 5 times 2 is 10 minus 6. That's 4. So this time, yes. There. That's better. Sorry, I'm trying to go so fast to get done with halfway through. We're almost there though. Same problem, same type of problem. So a lot to practice here. Another similar problem, a lot to practice for you. Another one. So I'll let you do those. All right, let's look at this one. Is the function given by g of x continuous at x equals 8? Why or why not? Well, the first step is to calculate the function value. So G of 8 is the first step when you're trying to decide if something is continuous. So this is number 45. And I'm going to copy this function down. G of x equals 1 over x squared minus 11x plus 24. And we're looking at x equal to 8. Okay, so again, there are two requirements for continuity. The limit has to exist on the left and right, and the function value has to exist. So I'm going to start with the function value because that's usually the easiest to calculate. So I take my 8, I plug it in here. I have 8 squared minus 11 times 8 plus 24. And that's going to be 1 over 64 minus 88 plus 24. And you can kind of see where this is going. 24 plus 64 is 88 minus 88, 1 over 0, that's undefined. You cannot divide by 0. So therefore, because the function value is undefined, it does not exist, and therefore it's not continuous. There's a hole there or a break, probably a break of some sort. So that's your first step. If you want to test for continuity, plug it in to the function. Okay. And so that one is not continuous because your function right here, the function is not continuous at x equals 8 because g of 8 does not exist. So right there. Oh, I guess I didn't do they want the left and right hand limits also. But that is true. It does not continuous because this, I guess it says select all that apply. So I better look for something else. If you test the left and right hand limits, you're going to go off to infinity. So I should also check these other choices down here. I thought it was one or the other, but it's all that apply. So the function is continuous at x equals 8 because g of x, no, that's not right. The limit does not exist. There we go. Okay, there we go. That's correct. Got to read the instructions. Check all that apply. Okay. I'm pretty sure there's a problem like this on the test. So this is again where the two sides have to match and you have to find the k that makes it work. It's just written in a applied problem. So we have a function that describes the charges $1.40 per pound and a surcharge if x represents plus a quantity surcharge k. So if it's less than 35, it's just $1.50 times x. But if it's more than 35 pounds, it's $1.40 plus some surcharge. So we just want to know, is this a continuous function? And how do we get, what's our k value to make it a continuous function? So I'm going to copy this down. P of x is equal to 1.50x for x less than or equal to 35 and 1.4x for plus k when x is greater than 35. Okay, so there's our problem. I think I copied it correctly. Again, in order for it to be continuous, the two pieces have to match up. So I plug in the 35, 1.50 times 35. And so we're checking the left and right now we're checking the left and right hand limits. So let's see, 35 plus, let's see, half of 35 is going to be 17.5 plus 35. Let's see. And I get 52.5. Then we plug in the 35 here. And to simplify that, I think I'm just going to use my calculator. So we have 1.4 times 35 is 49. So this is going to be 49 plus K. And we want this number and this value to match. So 49 plus K is equal to 52.5. So K is going to be, subtract 49 from both sides to get K. And it's going to be 3.5. So that is in dollars. So $3.50. Okay. So that's how you do that one. Just plug in the number. By the way, this also, the second thing that you have to check is whether the function value exists, and it has to be equal to your limit value. So here we have the limit, the left and right hand limits are going to be 52.5. So the limit as x approaches 35 of our function p of x is equal to 52.5. And when you plug in 35 right here, x equals 35, you plug it in, you get 52.5. So the value at 35 is also equal to 52.5. And this is the requirement for continuity. You have to have the limit exist, and it has to equal the function value. So there you have it. And we're pretty much at the end here. Let me just check. I wanted to get through 50 problems because that's the halfway mark. So let's see if there's anything. I think I'll just wait till the next class period to do this one. This is a whole new topic. We're at the end here. So I did get through about half, and I'm going to record this next period, the rest of the review. I'll send an email with those links. So you have that to review if you need to. I mean, you could just work on the review yourself if you know how to do it by yourself, and you're good to go. But this is it. It's going to be available for you. So, okay. Any questions or anything? So see you on Tuesday at upstairs room 3000. Just bring a pencil. I'll provide scratch paper and everything else. You're welcome. See ya. Have a good one.
I was a few minutes late to class. Can I get on the attendance, please?
You know what? I didn't take attendance today because of the review. We didn't have a participation grade, so you're good. You're good to
Okay.
go.
Thank you.
Uh-huh.